Welcome back. Today we are going to discuss about a problem on star delta transformation. Here a circuit is given. The question is to find out the resistance between the points A and B. You can see the resistors are connected across the terminals AC, AB and BC, also in between DF, DE and EF. We have to find out the total resistance between the point A and B, or we have to find out the equivalent resistance of the circuit R in between the terminals A and B. We have to find out this resistance. So here in this problem we can see that there is a delta network here. This D, F and E constitute a delta network. So we can convert this delta into a star network. Here, since we have a delta network, this DEF, the terminals DEF constitute a delta network. Our first aim is to convert this delta network into a star network. So if we draw a star network inside this, we have to convert in between these points into a star network here. So what I am going to do is I am just drawing the inner loop, that is DEF here. Each of the resistors are having 1 ohm resistance. So this is the inner delta connection, that is DEF, and we are going to convert it into star connection. So we can find out the resistance using the equation. Let the resistances are RA, not RA, let the resistances are RE, RF and RD with respect to the terminals. RD equals 1 into 1, that is the opposite resistors, adjacent resistors divided by the total resistances. So 1 plus 1 plus 1, that is equal to 1 by 3. Similarly, RE equal to 1 by 3 and RF, that will be also equal to 1 by 3, since all the resistances in the delta network is same. So now we can change or redraw this circuit. We can redraw it. The inner delta loop, that is converted into a star. We can redraw the circuit now. So here we can see that these resistances are the inner loop resistance that we have converted delta into star, and each of these resistances are of the value 1 by 3. Now you can see that this 1 and 1 by 3 are is connected in series, and again here also these two resistances, they are connected in series. Here also these two resistances are connected in series. So we can rearrange or redraw the circuit. So the series components, series resistors 1 plus 1 by 3, that is equal to 4 by 3. The effective resistance at that points will be 4 by 3. Now we can redraw the circuit with this resistance value. So this circuit indicates that the inner star connected network, that each of the branch is having two series resistors. So the effective resistance, that is equal to 4 by 3, and we had replaced these two resistors, that is series combination, into a single resistance. So we can see that now this circuit is in such a way that the outer loop is delta connected and the inner loop is star connected. Now we can convert this inner star connected loop into delta. That means there is this inner loop, each of having resistances 4 by 3. So we can convert this inner loop into delta, 4 by 3 and 4 by 3. So how can we convert that? Using the equation of star to delta transformation. So here we have to convert this star connected network into delta. So let the delta connected network, we can name the resistance of a delta connected network. Let it be RAB, RAC and RBC. Now we can write the equations. RAB equal to, we know we have to take the sum of product of all pairs, all possible pairs. So it is 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 divided by 4 by 3. So if we calculate this, we will get it as 4 ohm. Similarly, RBC is equal to the same equation, 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 plus 4 by 3 into 4 by 3 divided by 4 by 3. It will be again equal to 4 ohm, and RAC will be also equal to 4 ohm. So we can now replace this star network into delta, each of resistance 4 ohm. So now we are redrawing. This circuit. Here this is actually the outer delta loop with the given resistors 3, 2 and 1. Now we have an inner delta loop, each of having the resistance 3 ohm. So we can draw the inner delta loop here. So this inner delta loop also having the resistances each of having the resistances, we got it as 4 ohm. Now you can see that this 3 ohm and 4 ohm that are connected in parallel. Okay, now we can see that the 3 ohm and 4 ohm resistances, these two resistances are connected in parallel. Again these two resistances, 4 ohm and 2 ohm resistance, are connected in parallel, and this 4 ohm and 1 ohm resistances are connected in parallel. So we can we can find out the equivalent resistances for each of this parallel connection. So corresponding to the terminals, corresponding to 3 and 4, 3 parallel 4, that is equal to 3 into 4 divided by 3 plus 4. Corresponding to 4 parallel 2, that is equal to 4 into 2 divided by 4 plus 2, and 4 parallel 1, that is 4 into 1 divided by 4 plus 1. So these are the values of these parallel resistances, the equivalent values of the parallel resistances. Now we can redraw the circuit with these values. We can redraw the circuit with these values. So now we only have a delta connected network, and we have to find out the resistance between the points A and B. That is our question. So the parallel value of 3 and 4 ohm resistance is 1.7. Here it is 4 parallel 2 is 1.33, and here it is 0.8. Now if you want the resistance between A and B, or the resistance RAB, the equivalent resistance between the terminals A and B, we can look here. These are the points. We want the resistance in between these 2 points, right? So if we check, we can see that if we want the resistance between the points A and B, this 1.7 resistance and 1.3 resistance that are connected in series, 1.7 resistance and 1.33 resistances that are connected in series. So in order to find out the equivalent resistance between the points A and B, this is the point A and B. Here the resistance is 0.8 ohm, and we can see that in order to find out the equivalent resistance between the point A and B, this 1.7 and 1.33 that are connected in series, then the equivalent resistance will be 1.7 plus 1.3, that will be approximately equal to 3. So I can write it as 3.33 ohm. Now these two resistances, that is 3.3 ohm and 0.8 ohm, that resistances are connected in parallel, and RAB, that is the equivalent resistance between the points A and B, equal to 3.33 into 0.8 divided by 3.33 plus 0.8. That is equal to 0.64 ohms. That is equal to 0.64 ohms. Now again I am going to so we have got the answer, final answer, that is RAB, or equivalent resistance across the points AB, that is equal to 0.64 ohms. Now again I am redrawing the circuit. Here 1.7, 1.33 and 0.8. Now if you want, now if you want to find out the resistances between the point, if you want to find out the equivalent resistance between the point A and C. Now if you want to find out the equivalent resistance between the point A and C, that is RAC. So what will happen? You have to find out the equivalent resistance between the point A and C. Now if you want to find out this, you can see that these resistors, that is 1.33 and 0.8 ohm, that will be connected in series. This 1.88 and 0.8 ohm, these two resistances will be connected in series, and the equivalent resistance across the points RAC. So if these two resistances are connected in series, 1.33 plus 0.8, that is equal to 2.13 ohm. Now we can redraw the circuit like this. in between the points A and C, there is a 1.7 ohm resistance is there, and we can see that this 0.8 and 1.33 will be connected in series. The effective resistance is 2.13. Now we can see that these two resistors, that is 1.7, that is connected in parallel with 2.13, and RAC equal to the parallel combination of these two. RAC will be the parallel combination of these two, and the equivalent resistance between the point A and C is equal to 1.7 into 2.13 divided by 1.7 plus 2.13, that is equal to 0.94 ohm. Similarly, you can find out RBC, that is the equivalent resistance between. So please find out the RBC on your own and write down the answer. The procedure is same as the previous, that is the steps to find out RAC and RAB. You can find out RBC, that is the equivalent resistance across the terminals B and C. So here we have got an star and delta connected circuit. So first we have converted the inner delta connection. You can see that there is an inner delta connection that we have converted into star. Then once we have converted the inner delta connection into star, we have got all these sums, these resistors are connected in series. Now by series combination, simplified this circuit using the series combination of resistances. After that, we again get an inner combination, an inner star connection. This star connected network is again converted into delta. So now these two resistances 3 and 4 that are connected in parallel, here 4 and 2 that are again connected in parallel, and 4 ohm and 1 ohm that is again connected in parallel. So by using the parallel combination approach, we have simplified the circuit like this, and we will be able to find out the values of resistances between the terminals AB, BC and AC. So thank you.